Hey there, today's topic is translation. Translation is important when it comes to the calculation of kinematic properties. Roughly spoken, kinematics describes how bodies move. In order to make things easier, within this tutorial we want to describe the movement of a single point. Let's take shot putting as an example. In order to achieve a long distance when throwing a shot put, the shot put needs to be moved in vertical and horizontal direction. In order to capture the movement of the shot put, we take advantage of biomechanical measurements. Biomechanics deals with quantification. For example, the estimation of a point with respect to time. Hereby, the time plays a major role. The symbol for time is t, and the unit is second. As it can be seen in this table, distance, velocity and acceleration stand in relation to time. Let's make an example. The line shows the distance run by a sprinter, let's say Usain Bolt. After 10 seconds, Bolt crossed 100 meters. In order to facilitate things, let's say the trajectory of Usain Bolt is uniformly distributed. This means that we know the distance traveled or covered after 4.5 seconds, which is 45 meters. How does the velocity curve look like? If Usain Bolt needs 10 seconds for 100 meters, his velocity is 10 meters per second, assuming a starting velocity of 10 meters per second as well. If a movement is uniform, the velocity is constant. If the velocity is constant, how may the acceleration curve look like? Let's clarify the meaning of acceleration. Acceleration means the change of the velocity within a time frame. Let's assume the velocity of a professional sprinter is approximately 10 meters per second. And let's say this time frame here holds the value of 1 second. The gradient at this point in time could look like this. The gradient is represented by a black arrow, by the way. This process to estimate the velocity from given distance points is called differentiation. Contrary to differentiation, there is integration. Integration means that the area below this curve here is summed up within each time frame. What might be the field value of this green area? The answer is 10. You just multiply height and width of the green area, which is the time point times the distance covered. Continuing this calculation, you can estimate the distance covered by the runner after 2, 3, 4 and more seconds. Now, how does the acceleration curve look like? It is 0, because velocity doesn't change. Regarding the velocity curve, there is no steam or gradient. Before quitting this tutorial, let me ask you guys, how does the acceleration and velocity curve might look like considering this distance trajectory? Thank you very much, and let's say bye for now.